I'm sharing the screen. Hope you are able to see now the notes here.
Yes, sir.
Okay, very good. So, right. So, before we, I myself discuss some of the aspects, as I mentioned, the important elements of math that are needed. So, let us start with linear algebra, and I suggest you to tell, okay, what all you know in linear algebra. So, let us start with the vectors. Okay, so let x be a vector. So, x1, x2, and so on up to xd. Okay, of d dimensions. Okay, it's a d cross 1 vector. Okay, and in our case, or in our examples, what do you think x1 to xd will be?
Features.
Yeah, are features. Okay, these are all features for our applications and our like modeling. Okay, good. And given these features, say assume that I may have some problem wherein I want to find between sample 1 and sample 2. Assume that this is one sample, sample 1, and I may write say y. Okay, this is also features of another sample y1 to yd. Okay, these are all the features of another sample. This is sample 1 and this is sample 2. Okay, so this also has d features. Now, between these two samples, assume that I want to find similarity. Tell me quickly, do you know any methods of finding similarity between these two samples? If I give you this information.
Correlation and mean square distance.
Very good. Oh, x and y. Okay, samples x and y. So, as essentially one way is the Euclidean distance, somebody has said. Okay, so it is, how do I find x minus y? Okay, this is the Euclidean distance. Essentially writing x1 minus y1. I think this is all known to all. Okay, xd minus yd. Is this correct or not? This is referred to as norm. Okay, and this is also referred to as second norm.
L2 norm, right?
Yeah, this is referred to as, okay, L2 norm. Okay, so this is referred to as norm in general. Okay, I can also find the distance in different ways. This is referred to as Euclidean distance. Fine. Is there any other ways of finding distance?
Dot product.
Okay, dot product will move on, but that's not a distance, right? Is there any other ways of finding distance? This is referred to as L1 norm. Okay, x1 minus y1. What is this single line indicates? Absolute. Okay, so I'm just finding the absolute difference between the features. Okay, and then I'm trying to say how close they are, how different they are. Okay, so this is L1 norm or mean absolute distance. Or absolute distance here, sum of absolute difference.
So you are breaking, sir.
Okay, you're not able to see now?
Sir, we can see, but audio is breaking.
Okay. Oh, fine. So you're able to listen now or not?
Fine, sir.
Yeah, fine. Okay. So we'll move on. If you have still a consistent problem, let me know. Because anyway, we have only 10 minutes time. We'll move on. Okay. So, and this is now L1 now. This is mean absolute difference. Okay. So this, if I divide by the total number of features here, then I will say mean. Otherwise, it is just a sum of absolute difference. Okay, of features. So it is better to say, since I have only two samples, I am finding this is absolute difference. Okay, I am finding. Okay, fine. So these are the other ways of finding. These are ways of finding dissimilarity. Okay, these are not the ways of finding similarity. Okay. Okay, now can some of you tell what are the ways of one similarity metric? Hello?
Dot products.
Yeah. So features are, say, samples. So one way to find is I write S of X comma Y. Okay. X dot product with Y. What is this dot product? How can I write in other words this dot product? I just want to write in little more another notation. How should I write this? Please note that for all our discussion is a vector. Okay, and then Y is a vector. Yeah.
X transpose Y.
Right, very good. Okay, so I can write this as X transpose Y. Is there any other way I can write? Is there any other way I can write? This is D cross 1, D rows and 1 column. Okay, this is also D cross 1. Okay, did I write correctly? Yeah, that's fine. Okay, so this is D cross 1 and D cross 1. So, and hence X transpose Y is what dimensions? This dot product is of what dimensions?
One by one.
Scalar scalar. Okay, so is there any other way of writing this? Can't I write Y transpose X?
Yes, sir.
So I can also write Y transpose X. Okay, fine. So, but this is a similarity metric, fine. But do you suggest that this is a very good similarity metric? Is this a very good similarity metric? See, what I do is, see, I have a sample. Assume that I have one sample. Okay, I have another sample. Both are images in terms of images. This is sample 1, sample 2. This I have taken with, say, good illumination conditions. So the intensities are in the range 100 to, say, 250. This I have taken in poor illumination conditions. These are 0 to 150. Okay, range. Now, I just want to do anyway, whatever, I want to find similarity and so on. Do similarity after extracting some intensity-based features. Okay. So do you suggest that, or do you tell that, is this a better way to find out the similarity? Or is there any better way of finding similarity?
Here also we should normalize.
Yeah, here also we should normalize. Okay. So normalized, so I should have a normalized correlation. This is also referred to as, this is correlation. Okay, somebody has said dot product, fine. Okay, it's also said as inner product. Okay, between the vectors X and Y. Okay, so these are all the different terminologies used. This is referred to as correlation. In fact, the correlation is a term that gives the similarity, or the dot product. Correlation means exactly dot product only. It gives the similarity. Now, what kind of correlation is this? Between two different samples. So it is referred to as cross correlation. Okay, this is a cross correlation. If I use same correlation with the same sample again, then I say X transpose X. Then in that case, it is Yeah, it is a
Autocorrelation.
autocorrelation, right? So if I use X transpose X, then it's an autocorrelation. Okay, otherwise it is cross correlation. Okay, so if I write S of X comma X, okay, if I'm finding X similarity between X and X, okay, X transpose X I will write. Sometimes capital T I may write, sometimes small t I may write. Okay, X transpose X is okay autocorrelation. Okay, fine. So now the question is, what we are planning to do is we want to do normalized cross correlation. What reason? For what reason are we doing normalization? For what reason are we doing normalization?
To have a similarity score.
Because X and Y
Yeah,
has no similarity.
Still, I
Because
could
the
not get. Yeah, I have written NCC here. Okay, so how should I write normalized cross correlation? X transpose Y by okay. With what should I normalize? Norm X, norm Y. Is this audible or not?
Yes, sir.
Hello?
You're
Yes,
audible.
sir.
Okay, fine. So why? Yeah. Why did we go for normalization? See, assume that I have two samples. Okay, one sample. One sample. When I made measurements. Okay, the samples have the values ranging from 0 to 100. Okay, another sample I have measurements from 0 to 1000. What I want to see is whether there is a circle shape or not. This is this circle and this circle. Okay, just I want to find similarity. Irrespective of the scale, I want to see the similarity. Then what should I do? If I do this normalization with the maximum feature I have, there is a hope that at least the scaling aspects or the feature measurement aspects, especially in terms of illumination and so on, okay, those aspects can be knocked off. Any feature, like while measuring the features, if there are any offsets or any scale variations that can be overcome or that can be better handled by normalization. Okay, so this is referred to as normalized cross correlation. Now, what do you think is the maximum value of this normalized cross correlation?
1.
What is the range of normalized cross correlation?
0 to 1.
Okay, so it is 0 to 1. Is this correct? No other suggestions?
Sir, -1 to 1.
Okay, fine. Somebody is telling normalized cross correlation can be -1 to 1. Okay, when is it -1 to 1 and when is it 0 to 1? Both are correct. If you have features, all features being positive, okay, then it is 0 to 1. And if you have both positive and negative features, okay, feature values taking both negative and positive, then it is -1 to 1. Is this correct or not? Is this clear or not?
Yes, sir. Can we have an example of a feature which will have negative?
Hello, are you?
So your voice is breaking.
Hello?
Yes, sir.
Okay, is this audible now?
Yes, sir. This is audible.
Okay, fine. Good. So probably we'll conclude this class here. Okay, because I think some students may need to leave to other class. So we will continue our discussion in the next class. Thank you then. Bye to all.